Hi and welcome to the Chennai AI Community Podcast, where we bring to you AI professionals from across the world. And today we have with us Vivek Menon.
Hi.
Hi, he's a senior AI ML engineer. And
So, thank you, Yousef. Thanks for having me. So, yeah.
great, okay. So, have you wondered how your taxi arrival time is calculated? Have you wondered how a particular YouTube video is surfacing to your recommendation system? That's part of AI, and ML plays a very critical role in that. So today our agenda in this podcast, what we are going to do is we are going to understand what is machine learning and how a machine learning project, the core of it, we are going to understand. And we have everything, let's say, covering from a student, he wants to get into AI ML, he or she, or a professional who is in a non-AI ML and they want to get into AI ML. And also for entrepreneurship, people who want to do and build some ML solutions for their businesses. So would love to hear from you, Vivek. How did you get started with AI?
Yeah, to be very honest, like my entry into this AI field was quite accidental. So, long story short. So, I will begin from my college.
Sure,
like,
we'd love to hear.
during my college days, I have faced a lot of setbacks, especially when it in the terms of arrears. Okay, so at that point of time, like arrears means, of course, there is no placement coming in my way. So luckily, I was able to pass out in the same year. Then what I done was like I took a step back to reorient myself. So at that point of time, I came across this institution called National Institute of Electronics and IT, which is a central government-based autonomous institution. So I enrolled for a short-term course there of 6 months, and I would say that was the real like game changer in my career, because there I happened to interact with lot of seasoned professionals, lot of highly qualified people who came there to pursue these short-term courses. So I mean, getting into that institution, I got this awareness on how these ecosystem work and what are the future trends and what's happening in this, like in the technical sphere. And from there, I get familiarized with this trending modern cutting edge technologies like artificial intelligence, IoT, big data. At least I get to know what those things are.
Okay.
Right after graduating from them, I got an opportunity with two companies. One was a embedded systems engineer position, and another was like IoT engineer position in a Calicut based startup. So I pursued the latter one, and so again that was an IoT based position, but later they were having some AI projects. They were into some kind of product development. So I was nudged into this AI project. So that's how I learned my basics with respect to AI and ML. These things.
That's amazing. Somebody who had, I can think about it like I had a max backlog as well.
Okay.
And I tried to clear it 2 times, but I think third attempt, but I got. That is a point when we feel that okay, our career, it might go nowhere.
Yes,
and if we
yes.
don't pass out on time.
Yeah, exactly.
And how beautiful is it that took you in a different path. It put you in IoT.
Exactly.
And from IoT, AI, and now you're in the best and the latest of technologies.
Yes, I mean, I will call it as blessing in disguise.
Blessing in disguise. So,
that's the apt term.
yeah, I think the key takeaway is that failures, obviously, I mean, that cannot just define what it is. The
exactly.
destiny has its own course.
Yes.
So, okay, so what is ML? I know ML is a subset of AI. So, if you can just tell us what is ML and.
Okay, so machine learning. So it's from that term itself is self-explanatory. Like what we are doing here is like teaching the machines, and how it happens is like, let's take an example. Okay, let's take a very classical example which you will come across in internet, and that is more relatable to the general audience.
Okay.
So let's take this case, for example, house price prediction. let's say you want to predict the price of a house at different locations of the world.
So let's say I'm a house owner and I want to know what is the best price I can probably sell or put it out to rent.
Yes.
Okay.
Yes. So in that case, we know like what are the contributors for the rent or price of a house, right? It's one of the factors like number of bedrooms. Another thing is like the square feet of the house. Another thing is like the other facilities like whether you have good water supply and all these other things, furnished, unfurnished, and of course location. That's also a key factor. So speaking in the ML terms or in the AI terms, these all are the features, our features that contributes to our target variable. Target variable is what? The price or the rent. Okay. So these are the key factors that plays the role in predicting our end result. So I mean, if when you encounter a data set, these two things you need to figure out.
Okay, so that's interesting. So house price prediction is something, yeah, I think it's very relatable for most of us.
Yes.
Okay, so different data, all this, yeah, pretty much this is going to be applicable for all over the world, right?
Yeah, exactly.
Location, amenities, bedrooms and all that. Okay. So how do we start? What is a typical?
All right. So it's like to begin with we need data. Okay. So it's similar like a preparation for an examination. So while you are preparing for an exam, first what you need the resource to study, right? Similarly, for machine learning models also, you need to have the data. Here, what kind of data you need? The data which has these parameters, I mean the relevant parameters that is necessary to predict the price of the house. And that can be from any source. That can be from some real estate companies, or that can be from government websites, or anywhere. I mean, the data can be anywhere. It's omnipresent, right?
Okay, so one way I'm seeing this is like most of the apartment colonies in Chennai and around. I mean, we use a particular app. So that particular app controls like the entry, exit, and people put out rentals. The flat is available for rent, and all this data is there.
Yeah.
The square feet and the number of bedrooms, the amenities, and the price. So if we have a partnership and we get the data from them, so that is a very real time data that people are using in that society. And
Yes.
Okay, makes sense.
So yeah, that's how these things works. Okay. So and another important aspect. So this is the initial part, which is the data collection. Okay. Once the data is collected, I mean, there are a lot of other hurdles that will come into picture. Like it's not necessary that whatever data we have collected is perfect. The real-time data will have lot of drawbacks. Okay. For one example, let's say in our data, there will be some missing features. Okay. For example, let's say you are looking for in your data set at a particular place, that place is not there. But that's very critical information, right? Because the price at Hyderabad won't be same as the price at Mumbai. And again, that will vary very differently with respect to San Francisco. So that is a very critical feature. And that's one of the major challenge which we would have to deal with the data set.
So let's say I'm posting an ad in the app in the community that we have a form where we fill the number of bedrooms, everything, and I forget to include the square feet.
Yes. That's also very critical aspect, because 3 BHK can be built in 1000 square feet as well as 2000 square feet.
Yeah.
So and the price of the house can vary in accordance with that.
So I think many of us we would be thinking that okay, the data, why there is a gap in data. So there is different systems that pull in this data. Let's say one of the sources, this particular app in the community where we somebody is posting this house information. The field for square feet is not marked as mandatory. So if it is not marked as mandatory, people might ignore that question and they may submit it. Maybe some other portal where this is there, let's say another provider in the city, it's not at the apartment level, at the city. So these guys have a mandatory point for including this square feet. So that's where the data inconsistency comes, is what I believe, right?
Yes. So yeah, I mean in real life data or real time data, there can be different such instances. Whatever you said is one classical example. I mean, likewise, there can be different instances that could bring data inconsistencies and missing data and all other things. So this missing data is a very important aspect which we have to deal with. Either we have to drop that, or we have to, I mean, there are a lot of other mathematical methods to take care of that. So I mean, that's pretty like technical. That thing we will discuss later.
So the basic first step is cleaning the data.
Yeah, cleaning the data.
Step 1, collect data.
Collect data.
Step 2, clean the data. Make sure it is ready.
Yes.
For the further stages.
Yes, and it is also said as data pre-processing part.
This is called data pre-processing. Where cleaning is done, where let's say a null values
are handled. Okay. And next comes the outliers. Outliers are like, for example, let's say there is a erroneous entry in the data set. For example, instead of 3 BHK, somebody has accidentally entered more 3s, like 333 BHK, like that. So and the price is like, let's say 50 lakh only. And we are pretty sure that you won't get, I mean, first of all, whether that kind of house exists is the first question, and whether it will be available for this price is another question. So that is known as outlier, like a value that varies significantly higher or lower.
Okay.
Or let's say if there is some negative value also, it's an outlier, because room can't be negative. So these kind of inconsistencies we have to handle first, because the system which you are training is as good as the data which you are giving. Let's say for an exam, I mean, your marks depend on I mean, the way you studied or how good you have studied, right?
Yeah.
Similar to this system also.
Makes sense.
So, that's the second step, data pre-processing.
So we got the data, we make sure that there is null values are handled, data cleaning and pre-processing, and outliers are being handled.
Yes.
Now the data is ready.
Once the data is well and good, there are also a lot of other things we will be doing, but these are the two major examples, so everybody can relate. Okay,
makes sense.
And once this thing is done, and now once our data is ready, then comes the algorithms into the picture, selection of the algorithms.
So if you can just explain what is algorithms.
Okay, algorithm here, let's say it's a teacher here in this case. So algorithm is, so when the data is given, the algorithm is the one who like trains the model or teaches the system on how to predict. And we have wide varieties of algorithms that helps to like develop these models.
So for different use case there are different algorithms.
Yes, because if we take our present case, this house price prediction, it's a regression use case. Regression use case means where you will be predicting a particular value. There is also another use case called classification use case. For example, let's say you have your health details, health vitals like pressure, cholesterol and other things. After putting it, there will be a target variable like whether you will get heart attack or not. You have that risk or not. That is a classification use case. Like this or that.
Makes sense.
And it can be multi-classifiers. So based on this thing, based on the use case, the algorithms will different. So there are some algorithms that can be used for both the use cases, and there are also algorithms that is specified to particular use case as well. So I mean that's what algorithm is.
So stage 3 is the selection of algorithm.
Selection of algorithm.
So let's say in this case you're talking about regression one.
Regression,
Is it one algorithm or it has?
No. I mean we can train with multiple algorithms, because algorithms capability and performance will differ from use case to use case. So let's say in this use case, let's take the case of this algorithm called linear regression. It may work very good in this use case, but it would perform very badly in some other use case. So the key here is like we will check with different algorithms, okay, and then we will choose the best performing algorithm based on our requirement.
So what would be like a place where you would train this? Because I think we cannot run it on our laptops, which is...
Yeah, I mean, it depends. For example, if you have a pretty, like if your data set is in the range of thousands, 10,000 and all, then you can run it in your local normal CPU.
Okay.
And Google provides this platform called Google Colab, where you will be provided with some basic GPUs. And see, all these things you can do for prototyping, studying and all these things. For enterprise level, that's a different story.
Yeah, somebody you want to learn and practice, or this?
Yes, Google Colab service,
where they can log in
and play around with because Google Colab comes with inbuilt GPU. I mean, it's basically a notebook where you have the provision to choose the GPU and all. So
yeah, we use it for Google Focus, but I mean that's a good way to practice. Okay, so now data is collected, data is cleaned, algorithm is selected. With the algorithm, the data is trained.
Yes. So there is one thing which you have to notice, like before training, we will split the data. Okay.
Oh yeah, that part.
Yeah,
that's true.
We will split it in 80-20 or 70-30 ratio based on the data availability, because we need to test it, right? Because we can't test on the trained data. Because if we test on the trained data, it will definitely give the correct results. But we want to make sure that our model has trained well, so that when an external data or an unseen data comes, it should give the right predictions.
Okay. So just to give a context, this is, let's say we have in an apartment complex data about 100 units. What is the average rental price which is let out? So out of the 100 units data that we have, 80 data will be taken for training and 20 for testing. That is, let's say 80 we train the model, and the last 20 we will take the model and test it, saying that is it going to rightly predict it. Because if I take, this is my apartment data and I know this is what the pricing is.
So, and also in your data you have the actual value and you will be having the predicted value.
Yeah.
Okay, so it helps you to understand how good this model is. Apart from the evaluation metrics, you can visibly see we
can see the actual results. So let's say in my area, in my apartment, for a 2 BHK, the rent is about 25,000. Okay, and I train the data at 3 BHK at, let's say, 35 or 45,000. So once the 80% data has been used to train, and I input that, okay, this is the square feet, this is what it is.
Yes.
What is the rent? If for 2 BHK, it's going to say that it is 25,000 or 26,000, that means our model is good. If it starts saying like 50,000, 60,000 for a 2 BHK,
then we have to revisit our data and see what went wrong.
Okay, so that's where the split of data is, like 80 and 20, to make sure with the outcome what we already have, we check.
We are just cross-checking. And from that data, we get this evaluation metrics.
That we get evaluation metric. Okay, that makes sense. Okay, so now the model is also created.
Yes.
The model is created, and what is a model? If you can explain how it looks.
So model is nothing but a file. I mean, it can be of different formats. In machine learning, it's mostly like in a pickle format, in PKL with an extension PKL. So that's how our model will looks like. It's nothing fancy, but a file format of PKL extension.
Yeah, when you hear AI models, it's something huge. It's just a file.
Yeah, it depends on use case and the volume of data which we train. If we have quite lot of volume, let's say if you are training on millions of data points, then the
Model
model
size.
will also relatively will be bigger, and also the computational intensity will also be more, and you would need much more better hardwares like GPUs and all to perform all these things. That's when this huge hardware comes into picture.
Okay. So when the model is ready, the model is out. This is not having the data.
Yeah,
data is separate.
Yeah, data is separate. It was trained on certain patterns. Okay, now the model has this ability to predict the things based on the data which it has studied.
Okay, so let's say I take this model, I deploy it, and my apartment in my area, I know this is 25,000 for 2 BHK. I take and deploy it to another apartment, which is maybe in the same locality, and we get their data and we ask it to predict.
Yes, yes.
So ideally, it should tell.
It should tell.
Yeah.
Yeah, that's where this concept called data drift and all comes into picture. Okay, so your apartment may be some kind of premium kind of thing. Okay, let's say it's a gated community and all the things. But if you are going to predict it for a apartment where it's like an average or below average facilities and all, then your model is definitely going to fail. That's what this data drift is like.
Okay.
I mean, your data is like not good enough to, I mean, your model is not good enough to handle the data which is not related to, like the features or the because there is something different, right?
Makes sense. So let's say even the same model for my same apartment, next year the things might not be same.
Yes, yes.
2 years later, the same model,
yes,
the house prices, the inflation would have gone up.
Yes, yes.
And if it predicts, obviously this is the data.
Exactly.
At that time, how we handle that?
So that's where this MLOps and everything comes into picture.
MLOps, it's like a DevOps.
Yeah.
Okay.
It's like I'm speaking from the enterprise level. Okay.
Yeah.
So once you deploy your model, your job is not over. You need to monitor it continuously. Just like you said, after a couple of years, this won't be useful because inflation and a lot of other factors, right?
Yeah.
So eventually it will go up. So at that point of time, what we have to do is like we will monitor. Okay, what the MLOps things will do is like they will monitor the data's performance, and if they detect some kind of drifts, they will retrain it. Retrain with the new relevant data.
Okay.
And that's how these things works. So whenever there is drift, we need to trigger the training again, and MLOps helps you to achieve this thing automatically. I mean that end-to-end process, with the help of MLOps, they will automate and these things making life easier.
So these models, it can, for the deployment process, it can be deployed in cloud or in-house, or it depends on the organization or the entity's discretion.
Yes.
How they want it to be. Okay. So I think just to summarize, we started off with collecting data, cleaning data, choosing algorithm, and making sure
training
the data, training with the right algorithm, evaluating based on the data that we have, because we kept 20% data for testing, and 80% is what we use for training.
Yes.
Now we took the model file, the pickle file, and then now we have this pickle file. We can put it in AWS or any
cloud of your choice,
and then with the new set of data, it should start predicting. And if there is gap, which is the data drift or
data drift, model drift, concept,
this should be addressed by incorporating the MLOps, where a consistent flow of the next set of data and the next set of evaluation is there. So again, the new retrained model is deployed, and continuously this performs.
Exactly.
Okay. I think that's a very beautiful explanation. Thank you so much. I think you made ML easier and palatable and digestible for all of us, I guess. Okay. So, I mean, this is a very interesting field. Like somebody, let's say, who is from non-AI ML background. Okay. Somebody who is in a production support, somebody who is in any other support role, or even Java development. If can they get into this AI era and evolution and be a part of it?
Forget about Java developers and all things. I have seen people who are from the core engineering background. Like my previous company was a automobile company, and I have seen people transitioning from the core engineering field, automobile engineering field, to this data science field. And I have even seen web developers transitioning, and at least I know a dozen of people who has done transition, who has transitioned from different backgrounds to this field. So it's not a big deal.
Okay, that's interesting. That's very hopeful for many people, because I think when I had a chance to interact with few of them, they were like, "Oh, we are into this different background, and I think we missed the train and we cannot get." But I see what you're saying. So anybody can get into this. Like, so let's say somebody who's in cloud or somebody who is in business analytics, which is non-coding background, can they also come in?
Yeah, because see, this artificial intelligence field or the data science field, whatever it be, it is not just about coding. There are a lot of other stakeholders involved here. For example, there are data engineers, who channelize the data into the data lake, or wherever the data from different sources. They are responsible in that way, and for them the skill sets are different. And this business analyst is a very important position, because these people acts as a bridge between the business owners and developers.
Yeah.
The technical people. So that's a very critical role, because developers may not understand the business aspects.
Absolutely. Yeah.
So, and business aspect is a very important thing when it comes to data science and AI, because until or unless that context is not properly conveyed, then there is no use in developing solutions. So business analyst is another role, and let's say if you are good at visualization tools and all these things, and you have decent analytical skills, then you can go with data analyst roles. And if you are not interested in any kind of data numbers, these kind of things, still you have chance like this cloud engineer. With the help of that, you can help to deploy the solutions and be part of this ecosystem.
That's very wide range of it, like a typical IT project or a enterprise level. There are different roles and responsibilities. So I think that's very beautiful, where cloud technology, if somebody is in AWS or any other Google Cloud experience, if they are already working on cloud technology, if they are more aware of the AI based services in the deployment part, it might not be too much of a difficult transition.
Yes, correct. Because they can go through, they can play around the service and get an understanding on how to make use of it for this solution. So it's it's another set of skills which
not a drastic. Not a drastic. I have to from car. I have to learn how to fly a rocket. It's not like that.
Yes.
From a car, you just learn drive a van or truck
like that.
Yeah. So, okay. Similarly, the data visualization tools, many areas we use, the Tableau, Power BI. Even they can be a part of this.
And if they feel more comfortable, they can gradually transition also to data scientist position. So what I am saying is, like, a data science or ML engineer is not the only position that is creating impact. There are a lot of other people.
Anybody on ETL is, I see it's a welcoming field.
Yes.
Yeah. All
people can transition from here to there to here. Anything can happen, provided you have that enough fire to learn new things.
It will take some efforts to do that. Okay, this is with the professionals who are in the industry. What about somebody starting? Somebody who is probably has taken this AI related graduation, and somebody who has not taken it, but right now they see and they want to be part of it.
See, the thing is, like, I'm a person who is from electronics and communication background. Okay, so while passing out, after my graduation, I didn't had any idea on anything. I was not good at coding. I was a clueless guy. So the thing is like, to begin with, see, there are a lot of plethora of contents over there. Okay, we have YouTube videos, we have a lot of blogs, we have a lot of channels, and see, there are chances that you might get lost in that lot of knowledge.
Yeah, it happens to me as well.
Yeah. I mean, it has happened to everyone. Like,
Yeah.
it has happened to me, and I have seen it happening
Yeah.
now also. So the thing is like, when you start, you stick with a particular content, okay, rather than hopping around. You stick with some specific blogs or channels or whatever you felt you are comfortable with.
So let's say if I am somebody who is in the final year of my graduation, and okay, would it be wise that they try a little bit about, let's say, go and try a little bit about cloud, or they should have a basic interest in something? Let's say they try a little hands-on in cloud. There are a number of free courses,
Yes.
and like you said, Google offers and many other platforms where they can. Amazon offers some free tier. We can try hands-on.
Yes.
Try that and check. Or if they are into programming, they can try that and check. Take maybe a 3 to 6 months, explore the different avenues, and then niche down to one.
Yeah.
And go deep.
Exactly.
Okay.
Like, for example, they can, to begin with, they can learn about basic Python.
Mm-hmm.
Then they can slowly study on some statistics and all other things, because it is good to have some statistical and mathematical knowledge before you deep dive into the field of AI and ML. It will be a good thing to do, and it's recommended. Okay, it's not that, because in Python we have a lot of libraries that makes our life easier.
Mm-hmm.
But having a deeper understanding will help you to see the bigger picture and solve solutions in a much efficient manner.
Okay. So how do you keep yourself updated? What's your secret?
Yeah, okay. So I'm into this AI field.
Mm-hmm.
So you know that this is a field that dynamically changes. Okay, so every second new updates are coming, and for me it's important. For me to survive in this field, it is important to stay update on day-to-day basis, because I still remember, like in 2022 I went for a 10 days Kolkata trip. Okay, and coming after that trip, I felt like all my 4-5 years of experience is waste. Like, I'm not able to, was able to catch up with what's happening over there in this just 10 days. So that's when this ChatGPT was released, and lot of happenings was going around. So that's the one of the good thing as well as the bad thing with this field. Good thing is like, you have to learn a lot of things, and bad thing is also this thing. You have to learn a lot of things, because you need to stay updated in tech field to remain relevant, right? So that's an important point. And how I stay relevant is like, I religiously spend a few hours in reading, especially in different platforms. Like LinkedIn is a very important data source for me, because in LinkedIn I have a lot of connections in the similar domain, and industry experts and all those things, and these people will post the content relevant to our the field in which I work for. And so when we go through the LinkedIn and all, a lot of information will be coming into getting into our head. Apart from that, I also read Reddit, Quora, and different blogs, newsletters like Daily Dose of Data Science and Medium.
That's
blogs.
A lot of reading.
Yeah. I don't have any schedule, but I will make sure that I read at least 1 or 2 hours a day on what's happening around.
Okay, cool. That's interesting. I think you very clearly helped us understand world of ML.
Yeah.
Yeah, I'm sure all the viewers who are watching us would have enjoyed. So thank you so much,
Yeah.
Vivek. It was such a pleasure having you, and
Same to you.
we look forward to have you again
Yeah.
sometime, digging out some more ML concepts.
Yeah.
Yeah, cool.
Yes.
All right, thank you everyone for staying with us and watching this, and I hope to see you in the next episode. Until then, take care. Bye bye.
Bye.